Good evening, students. Today we are going to prove that the product of the finitely many compact spaces is compact. So now we prove the theorem by the mathematical induction method. So this is shown here. Now let us take two compact spaces, x and y are the two compact spaces, and script A be an collection of the open sets of the form of the Cartesian product x cross y. Now we have to show that this x cross y is compact. By the definition of compactness, we have to show that every open covering of x cross y has a finite subcover which also covers x cross y. Now we have taken an open covering script A which consists of collection of elements A1, A2, A3, etc. of the space x cross y. Now let us take a point x0, arbitrary point x0 belongs to capital X. Now, with the help of the point x0 and the elements of capital Y, we are going to generate a slice x0 cross y that is shown here in the diagram. In this diagram here, see here x0 is a point on the x-axis, and this straight line is called the x0 cross y is the slice. Now let us take an element a1, a2, a3, open elements or open sets of the form a1, a2, a3, am. Here we have to show that this slice x0 cross y has covered by a finite number of elements of the script A. These elements are a1, a2, a3, am. This slice x0 cross y is compact, therefore it is covered by the finitely many elements of script A. Name it as a1, a2, a3, am. So find the union of all these sets a1, a2, a3, am and name it as n. This n is also an open set. This open set shown here, this is the open set n. This open set n contains the slice x0 cross y. This n is obtained by unioning the elements of a1. a1 is a lower triangle and a2 is next triangle of elements a3, a4, a5. Union of all these open sets will form a set capital N. Now here the set W is an open set in capital X. Actually this W is obtained, this W is a neighborhood obtained by the neighborhood of the x0. So corresponding to each point x0 we can find an open set W. This W set is covered by the elements of W cross Y tube. This W is a set, and here the W is a set of all points. W cross Y is nothing but this is the entire tube. Here see here this line to this line. See the rectangle here. This W is called, this portion is called the W cross Y. Now corresponding to each open set W, we can find a tube W cross Y. This W cross Y covers the slice x0 cross Y. So therefore here for each in x we can, or that is how I have shown here. For each small x in x we are able to find the neighborhood Wx of x such that this W cross Y can be covered by the finitely many elements of script A. Now so here each W1, W2, since each W1, W2, W are the open sets of capital X and X is a compact set, so therefore By the definition of compactness, the finite number of open sets W1, W2, say Wk, this also covers the space X. So therefore, by considering the finite number of open sets W1, W2, W3, Wk, so corresponding to each W1, corresponding to W1 we can find the tube W1 cross Y. Corresponding to W2 we can find the tube W2 cross Y, etc. And corresponding to the open set Wk we can find the tube Wk cross Y. These we have found out the finite number of tubes W1 cross Y, W2 cross Y, etc. Wk cross Y. While we are taking union, this will give the entire set X cross Y. So therefore, entire space X cross Y is covered by the finitely many number of tubes W1 cross Y, W2 cross Y, Wk cross Y. Hence, by the definition of compactness, X cross Y is compact. Similarly, here in our study earlier, we have in our study we have taken two compact spaces X and Y. Similarly, we can extend the result to more number of sets. In the lower classes, we have studied that whenever the theorem is true for two sets, it is true for, assume that whenever the theorem is true for two sets, assume it is true for three sets. Whenever it is true for n equal to k, it is true for k plus 1 sets also. By applying this mathematical induction, we can prove that finite number of Cartesian product of the finite number of compact spaces is compact. So thank you.